I'm Molly, and today we're going to talk about Promptable, an AI assistant for your relational database design needs. So, who am I? I'm a software engineer with years of experience from smaller startups to FANG, and with every job I've done, there's always been a requirement for relational database design. I'm definitely not alone. Almost every backend dev will have a similar experience. So, let's go ahead and talk about a common scenario. Your product manager hands you a technical document describing a new feature, and he wants you to fit the new feature into the existing system. You're new to the team, and you don't know a lot about the ecosystem just yet. This is me whenever I get that request. All right, so how would I personally approach this? I would cobble together resources, read through documentation and code, and try to understand the existing ecosystem. Ideate at a high level on how to fit in the new feature, and once I settle on a high-level schema, I'd fine-tune the fields and constraints. It's very time-consuming, very tedious, and worst of all, super boring. So, what do? You think AI could speed up some of that? Out of the box, it already gives me some document parsing and simple SQL generation, right? But alas, you can't use it. You can't upload your company's proprietary data to the cloud. And even if you can, or you can use a workaround like LM Studio, you'll still quickly reach document upload limits. And even if you do have few enough documents, general AI systems just aren't really that well optimized to be able to handle complex data sets. And they just don't have great UX built up around database visualizations and editing. What is one to do? Ta-da! Promptable to the rescue. It's a lightweight, schema-focused, optionally self-hosted, AI-assisted relational database assistant. You can kind of think of it as an automated database administrator. All right, next up, we're going to get into the live demo. So let's expand a little bit upon our scenario from earlier. Let's say we work in a new healthcare startup, and we're making a patient tracking system. Just checking. You guys can still see my thing, right? Okay. There's an established standard out there called OMOP CDM that we want to use as reference, but on its own, it's a little too complex for our needs. So we're going to reference it to add appointment tracking to our existing database schema. All right, first things first, let's go ahead and ask it a question so that we can get up to speed with the documents within our ecosystem. So over here, we have our prompt. Up here, we have documents we can upload. I've already gone ahead and uploaded a couple of them just for the sake of this presentation. They are cached over here for us to be able to pull results from. And now we're going to go ahead and submit. And this should give us a good lay of our general high-level context within our systems to give us like a good understanding of what's going on. So you can see over here, it's referenced our dynamic document corpus over here to gather a short summary on what exactly is going on within those documents. Pretty nice. So let's assume this is enough for us to understand what's going on and for us to move on to the next step. Next things up, we're going to go ahead and ask it about our existing schema. So let's go ahead and upload said schema. I've already prepared one over here. And we're going to go ahead and ask it to generate us a summary of said schema. So let's go ahead and submit. All right, so over here, now it's pulling information from both the schema and also the context documents. If you give it a second, it should give us a result. All right, so you can see here we have 3 tables: concept, person, and observation. It's generated a quick summary of each table over here using natural language. And on top of that, it also has created a diagram for us showing us the connections between the 3 tables and also which ones are primary keys, foreign keys, and so on. Pretty nice. Okay, so from here, we established that we have a pretty good understanding of what's going on within our ecosystem. And we also have a feature that we need to implement. What we're going to be doing here is tracking patient visits as our PM requested. So let's go ahead and ask it to do that. I want to track when my patients visit their care provider. Update my schema to include that. So let's go ahead and submit. And now this is pulling information from our schema from before, our context documents. And what it should be doing is updating said schema to include our requested updates. So you can see here now that it's created a new table called visit occurrence. The new table visit occurrence also references the 2 tables within our existing schema, person and concept over here, to create essentially a new table with foreign keys that should link in well with our existing schema. So we could continue to iterate from here, but for the sake of time, we're going to get back to the slideshow. So let's go ahead and continue. All right, so Promptable has 2 modes of operation. There's the cloud-assisted mode, and there's the self-hosted mode. The cloud-assisted mode is a little bit more beginner-friendly since it lets you leverage OpenAI's managed LLMs. It also gives you the power of Google Search via Tavily. The self-hosted option is for the folks that truly have to deal with sensitive data, with schemas and documents that they can't upload to the cloud. It requires you to host your own Ollama instance locally. Okay, so let's go ahead and talk a little bit about what's going on behind the hood. There are three major steps going on here. We have data ingestion, context retrieval and answer generation, and answer translation. Let's go through each one briefly. All right, first up, we have ingestion, aka once we upload the document, how do we make it available to the rest of the system? Well, since we have two places where we can upload the documents, the schema and also the context documents, we also have two ingestion pipelines. So you can see over here with the ingestion pipeline over here for the schema, it's relatively straightforward. It has a custom SQL keyword split over here, but the context one has a little bit more going on. You can see that it's using underneath the hood semantic chunking, but on top of that, specifically for CSVs, I was finding while doing vibe checks that I just wasn't getting back any results with raw CSV rows. So what I did is add a natural language translator over here to convert each row to natural language such that it could be then retrieved by semantic retrieval. All right, next up, we have the agentic layer over here. This is where we're gathering context using our RAGs and generating an answer using our agent. So you can see the agent is hooked up to three tools. There's the existing schema RAG, there's the context RAG, and if you're using the cloud-assisted mode, we also add the power of Tavily so you can have access to Google Search. Okay, and last up, we have the translation layer, aka what are we doing to get those nice diagrams? So if we detect that our answer has a SQL block, we extract it and then use an LLM to translate it to mermaid ERD syntax. We then output that on a response and our front end renders it. Okay, so enough technical details. Let's talk money. All right, so first up, let's address the value addressable market. Globally, there are 27 million software engineers. Let's assume 25% of them are doing backend or data engineering, and 50% of those are doing some kind of database design. So that comes out to 3.35 million relevant engineers. Let's break down how much that costs per engineer. Let's assume an engineer spends on average 2 hours per week doing database design, coming out to 100 billable hours per year. And the global median pay of our relevant engineers is 150K. Putting that together, that gives us 7.5K per engineer per year spent on database design. All right, let's take a look at the numbers using Promptable now. Let's assume that Promptable gives us about a 50% efficiency boost. That gives us per engineer savings of 3.25K per year. And let's assume that we capture just 1% of the world's relevant engineers. That gives us 335K engineers. All right, so what does that give us? That gives us $108 million of created value. It's pretty powerful if you ask me. Okay, so let's talk a little bit about long-term vision as well too. Where are we heading with this? So right now, we're just focusing on relational database design only, but theoretically, once we've built up an established platform, adding support for additional dev tools is actually pretty feasible. So longer term, we'd like to become an all-inclusive AI-assisted dev design platform, sort of in the vein of other dev tool companies like Datadog and Amplitude. So how do we get there? Well, we need to continue building up upon our foundation over here. We need to improve our quality, coverage, and usability. So we're going to leverage a lot of the tools we've learned in class for quality assessment, Ragus, Lanesmith, and more. And we'll also use vibe checking for further test coverage, making sure we have good quality results across all kinds of inputs. We can also add some usability updates, making a feature to version and edit our schema updates. And since we're all aware of how documents can't capture everything, we also can add code as context too. Next up, we can also improve the way we're currently hosting. The cloud-assisted mode can be made into a fully cloud-hosted SaaS freemium model, and the on-prem mode can be optimized for enterprise. We can do some things here where we can hook up Promptable to an externally hosted Ollama instance and offer our consulting services as a subscription. And theoretically, once we get all of those working, we can start adding further dev tool support. Right now, I've flagged these, NoSQL document schemas, CRUD contracts, and GraphQL schemas, but there's potential for a lot more. The sky's honestly the limit here. We could take this pretty far. Thank you for joining me and listening to my presentation. Let's go ahead and take some questions.